The Dual Attitude and Heading Reference System, AHRS, is an inertial sensor system with inbuilt accelerometers and rate gyros strapped down to the main aircraft axes, controlled by two Attitude and Heading Reference Units, AHRUs, that compute and output attitude and heading to the PFDs and MFDs via ARINC communication buses, to the Auto Flight Control System flight guidance modules, and to the FMS. Note that the standby instruments are not connected to the AHRS. It also supplies data to systems such as weather radar, to the stall protection system, to the ground proximity warning system, GPWS, to TCAS, and to the flight data recorder. Inputs are from the air data computers, from magnetic flux valves on the wingtips that give bearings relative to the Earth's magnetic flux, and from AHRS controller panels. The panels display mode status. The AHRS has attitude and heading standard modes, reduced performance modes, as well as alignment and calibration modes. Calibration is a maintenance function. Operation of the AHRS is largely automatic. Let's look first at alignment and standard modes. Alignment mode starts at the end of a 5-second power-on self-test if there are no malfunctions. 20 seconds after the start of alignment, you should see the aligning message flashing, then go steady, and the normal AHRS indications: attitude on the EADI, heading on the EHSI, altitude on the altimeter, and vertical speed on the IVSI. If the aligning message does not extinguish after about 60 seconds on ground, you should realign by pressing the align switch light on either AHRS control panel. Don't move the aircraft during alignment, although normal loading and even engine starting can continue. AHRS alignment can also be performed in straight and level flight. The process should take about 90 seconds in flight. After alignment, if there are no flags, you are in the two standard AHRS modes: normal mode for attitude and slaved mode for heading. These attitude and heading modes are entirely independent. In flight, in the normal attitude mode, true airspeed from the air data computers compensates for acceleration-induced errors. Each AHRS computes its own true airspeed as a check. The vertical speed is calculated with barometric altitude from the air data computers and adjusted by acceleration measurements. In the slaved heading mode, the indicated heading is slaved to the magnetic flux valve heading, and the difference is displayed on the compass synchronization annunciator as either a plus or a minus. It's normal to oscillate between the two, as AHRS continuously synchronizes headings to the flux valve. During a turn, one symbol may dominate, while AHRS resynchronizes to a changing heading. The AHRS control panels on the forward pedestal let you adjust for errors and show the status of reduced performance modes. Firstly, basic attitude mode. If true airspeed from the air data computer is lost, AHRS goes automatically into basic attitude mode, and the attitude heading and reference unit behaves like a conventional vertical gyro. You can manually revert to the other side ADU input. Touch the ADC source knob. The basic mode light should extinguish, since true airspeed is now coming from the other side's ADU. Now slave heading faults. If you see a heading flag on an EHSI and a red slave fault light on the AHRS controller, then the magnetic heading reference is invalid, probably a flux valve failure on one side, so normal flux valve slaving is not working. It may be possible to remove the slave error by selecting and immediately deselecting directional gyro, DG mode. Touch the DG button to quickly select and deselect it. This action resyncs to the flux valve heading without affecting attitude. But if this doesn't work, and the heading flag and the slave light stay on, try reverting to the opposite side's AHRU. Touch the attitude heading source knob on the ESID panel. If the failure is still there, you should return to the normal AHRS source and select the reduced performance DG mode. Touch the DG push button on the AHRS control panel. In directional gyro mode, the flux valves are removed from the heading computations. You see the DG flag on the EHSI to remind you, and the slave error is still there. Notice that there's no compass synchronization annunciator. DG mode often occurs when flying close to the Earth's magnetic poles. In DG mode, you can correct the heading for gyro drift by setting it to a known heading source using the DG slew push buttons. Pushing this button gives 1 degree per second clockwise rotation of the compass rose. Pushing and holding this one for more than 3 seconds gives a fast slew of 10 degrees per second counterclockwise. In directional gyro mode, you should slew the heading to a known heading source about every 5 minutes to correct drift and acceleration-induced errors. You can try to go back to automatic slaving of the heading to the flux valve by pressing the DG button again. Some AHRS flags and limitations. Each attitude and heading reference unit monitors input data from its own side air data unit. If an ADU fails, then the other feeds both systems, and you see the ADC flags on both PFDs, indicating that both AHRUs are being fed from a single source. After an AHRS failure, and you select attitude and heading reversion from the good side on the ESID panel, you get the attitude and heading flags to remind you that there is only one AHRS source. If you're forced to switch to DG mode in this situation, you get DG 1 or 2 instead of the normal DG. Finally, there are important limitations associated with the AHRS system. Takeoff in basic attitude mode or DG heading mode is prohibited.